Alright, today it's going to be a rather quick video. We're just going to go over the first part of 2.5 homework. It's 1, 2 to 10, even. So just 6 problems. Hopefully you've already attempted all these problems and you're just checking your work, because really we spent an entire period almost working on this. So it shouldn't have been homework, to be honest. It's really just more in-class work. So technically it was an in-class assignment, but maybe you didn't get the work done, so that's why you're here. Okay, moving on. Alright, number 1 just says state the remainder theorem. And we talked about in class that you could have used the back of the book to get a real math technical definition. And if you have what the back of the book says, I'm just going to ask you to put it in the words that that I can understand and you can understand. So I'm not really going to accept what the book has, because I don't think most people are going to be able to understand what that means. So the remainder theorem in our kind of world, our words, just says if something does not divide evenly, it has a remainder. And we showed that in class. And the most important part, that remainder gets added to the quotient, and that's the answer. That's just so you might have added to the answer. On top of the divisor. And that's it. Alright, so number 2 says we need to use the problem in the book, shown in the book, right here, has already been divided using synthetic division. And we're going to talk about synthetic division, that it's a faster, more efficient way to do division. Now, this is going to look a little bit different than what we've seen. So you had to actually read it, and then that's going to tell you what exactly that you're going to do. So in order to figure out this, you would have to look on page 121 is where your solution is going to be. All right, and that's going to give you the information about what those coefficients, what those numbers mean. And the red numbers, so these red numbers, those are just the numbers of, or they're the coefficients of your quotient. So they're just the numbers in front. You have to add the variables. That's what we're going to talk about tomorrow. All right, the blue numbers right here, or it's actually just blue number, not numbers, just one number. That's your remainder coefficient, or just your remainder. All right, and we're going to talk about how to do all that stuff, coming up. All right, moving on. All right, so to do polynomial long division, you need to first, remember we said in class that you need to figure out the first step 1 was to make your division box. So that's all I'm going to do is I'm going to make my division box. And I'm going to put something on the outside, something on the inside. X minus 5 goes on the outside. And 3x squared minus 11x minus 26 goes on the inside. I ask myself really quickly, can I count down to 0? I start with 2, then 1x, then no x's. So x to the second power, then x to the first power, then no x's. That means I can't count down to 0. I don't need a placeholder. And on the outside, I don't need a placeholder because I have x to the first, and then no x's. All right. Step 2, remember we said line leaders. In this line right here, on the outside, x is the line leader. On the inside, 3x squared is the line leader. So there was 2 ways to do this. In class we said, well, x times what is going to give me 3x squared? And the only thing I can think of to give me 3x squared would be 3x. So I put 3x right here. This 3x goes right there. Right? Or if you really don't like using that method with the multiplication, you can use division where you take your top line leader, divide it by your outside line leader, and you get the same thing, 3x. Right? It gives you the same thing. This 3x and that 3x, they're the same 3x. They go right there. Now, just like in long division with numbers, you had to multiply whatever you put on top of the box by everything on the outside. So I do that. 3x times x, 3x squared. 3x times minus 5 is minus 15x. Now, the most common mistake that people make is they forget that you have to change the signs before you go any further. So I change both signs here. I make that a minus, I make that a plus. That's me changing the signs. Now I can combine my like terms. 3x squared and minus 3x squared? Well, it's just 0. And I always do this step. The book never shows that step. I always do that. It's like a self-check along the way. If that 0 doesn't show up, that means I made a mistake somewhere. But it does. Negative 11x and 15x together, that's 4x. And just like in long division with numbers, everything else drops down. So this becomes minus 26. Okay. Now, I just rinse and repeat. So now I'm still focusing on my x here. That's still my line leader. But now, my new line leader is 4x. So I need to pick something that's going to give me 4x. Well, if I already have 1x, the only thing I can multiply to get 4x is just 4. So I put plus 4 right here. Notice, if you line everything up like I am, like I lined up my x's are lined up, and then my 1's are lined up, I know this should not have an x. It's like a self-check as I go. I multiply 4 by everything on the outside, I get 4x. 4x times minus 5 is minus 20. Well, remember, you still have to change both signs. So I make that a minus, I make that a plus. Most common mistake right there. People forget to change signs. 4x minus 4x, 0, that's just my self-check. Negative 26 plus 20 is minus 6. And look, if you lined everything up, you're already out of room. There's no more room here. So I'm telling that tells me right away I think this is my remainder. And just to double check, if I have x, there's no way I can multiply by anything to give me negative 6. So that's my remainder. So my final answer is just 3x plus 4. And remember, the remainder theorem tells us you add that remainder, negative 6, put it over your divisor, x minus 5. And that's my final answer. Moving on to 6. Alright, number 6, we have 8x squared plus 34x minus 1 divided by 4x minus 1. So remember, once again, step 1, said to make your box. Make your division box. And that's all I do right there. I just make my division box. I put 4x minus 1 on the outside, because that's after the division sign. That's why it's on the outside. This whole thing goes here on the inside, so it's 8x squared plus 34x minus 1. I don't need a placeholder because there's x to the second, x to the first, no x's, that's 2, 1, 0. X to the first, no x's, that's 1, 0. So I don't need any of that. Step 2, remember, step 2 says focus on your line leaders. So we're going to look at our line leaders. Line leaders. So I have 4x and I have 8x squared. Well, 4x times what is going to give me 8x squared? Well, 2x. 4x, because 4 times 2 is 8. X times x is x squared. So I put this 2x right there. Remember, if it's on top of the box, you multiply by everything inside the box. 2x times 4 is 8. 2x times 4x is 8x squared. 2x times minus 1 is minus 2x. Don't forget to change your signs. Most common mistake. So I make that minus, makes this plus. 8x squared minus a squared, 0. That's my self-check. If that 0 doesn't show up, that means I probably made a mistake somewhere. 34x plus 2x is 36x. And then I just drop down the minus 1. Now remember, 0 is not really there. It's not there. So when I go to my next step, I'm looking for the line leaders. This time I have 4x. That doesn't change, but my new line leader is 36x. So I say 4x times what is going to give me 36x? Well, I don't need an x because I already have 1x. I don't need another one. So I need a number. 4 times what is going to give me 36? 4 times 9. So I put a plus 9 right here. Notice, if I lined everything up, I started with x's. That means my next number should have had just a number. So if I had like 9x squared or something show up, I know I made a mistake somewhere. But I didn't. So 9 times 4 is 36x. 9 times negative 1 is minus 9. Once again, don't forget to change your signs. Even though it's the last step, you still have to change your signs. That makes it minus. That makes it plus. Plus 36 minus 36x, that's 0. Negative 1 and 9 is 8. That's my remainder. Now remember, your remainder is, if you lined everything up, you know it's your remainder because you're out of space. Also, 4x, there's no way I can take 4x and multiply by anything to get 8. So my final answer is 2x plus 9, that's from the top, right here, plus my remainder, that's from right here, over my divisor, which is 4x minus 1. Remember, that's what the remainder theorem tells us. That's my final answer. Moving on. Alright, number 8, we have 7x cubed plus 11x squared plus 7x plus 5, all divided by x squared plus 1. So once again, step 1 says we make our box. On the inside, I put 7x cubed plus 11x squared plus 7x plus 5. On the outside, I put x squared plus 1. Now I just start. Once again, I am starting with my line leaders. I have x squared, I have 7x cubed. X squared times what is going to give me 7x cubed? Well, in my opinion, it's 7x, because 1 times 7 is 7. I have 2 x's, so I need one more. That's why I put 7x. So I put 7x right here. 7x goes to everything. 7x times x squared is 7x cubed. 7x times 1 is plus 7x. Don't forget, change your signs. So I make this minus, I make this minus. And now I combine my like terms. Look, my 0 shows up. 11 minus 7 is 4x squared. Okay. Then I drop down the 7x and the 5. So it becomes plus 7x plus 5. Rinse and repeat. Alright, now I have new line leaders. X squared is my line leader still, but now I have a 4x squared. So I have x squared times what is going to give me 4x squared. I already have the 2 x's, so I just need a 4, and that's what I'm going to put here, plus 4. 4 goes to everything. 4 times x squared is 4x squared. 4 times 1 is plus 4. Now I'm going to change both my signs. 4x squared is negative, which makes this 4 negative. My 0 shows up. Now I'm left with 7x minus 4 is 3x plus 5. And that's my remainder. It says that's my remainder because I'm out of space. So my final answer becomes 7x plus 4 plus 3x plus 5 all over x squared plus 1. And that's my final answer. Alright, last problem we're going to go over today is 4x to the 4th plus 5x minus 4 divided by x squared minus 3x minus 2. First thing I'm going to do is I'm going to make my box. On the outside, really easy, x squared minus 3x minus 2. Remember, if you count down, I have x to the second power, start with 2, then x to the first power, that's 1, and then no x's, so that's 0. So that counts down just fine. Now when I start here, I have a 4, but I don't have x to the third or x squared. So I'm going to add those in. Those are going to be my placeholders. So don't forget placeholders are needed for this problem. So I'm going to put 4x to the 4th. I'm going to put 0x cubed. That's my placeholder. And I'm going to put 0x squared because that's another placeholder. And then I put plus 5x. And then I put minus 4. And I just continue to go just like I did everything else beforehand. So I still start with my line leaders, x squared and 4x to the 4th. So x squared times what is going to give me 4x to the 4th? So I'm going to put in 2x squared right here because I have x squared. I need 2 more x's to get x to the 4th. And actually I don't want 2. I want 4. Because 1 times 4 is 4. So I'm going to put 4x squared. And notice, now that I put my placeholder in, I have a place to line up that 4x to the squared. So then I multiply everything. 4x squared times x squared is 4x to the 4th. 4x squared times minus 3x is minus 12x cubed. 4x squared times minus 2 is minus 8x squared. Alright, I still have to change my signs. So I still have to make this, I still make that minus, I make that a plus, and I make that a plus. And notice, now that I have my placeholders here, it makes it really easy to see where everything goes. So this turns into a 0, 0 and 12, so it's 12x cubed, 0 and 8, so it's 8x squared, and I just drop down the rest of it. I drop down 5x, I drop down negative 4. And remember, we just rinse and repeat, so we're going to just go through the same thing again. This time, x squared is still my line leader, but now I have a new line leader. It's 12x cubed. So I'll multiply by something to get 12x cubed. Well, I need one more x, that's why I put an x there. And notice, my next space right here has an x term. So that tells me that it should only have an x, not an x squared, not no x's. It tells me it should probably have an x. And then I'm going to put a 12 here because 1 times 12 is 12. So that's how I get 12x cubed. So my spot right here is going to have 12x. And then I multiply 12x by everything again. So 12x times x squared is 12x cubed. 12x times minus 3 is minus 36x squared. 12x times minus 2 is minus 24x. Now, remember, you have to change all your signs. So I make that minus, that becomes plus, that becomes plus. This turns into 0 just like I want. This turns into 44x squared. This turns into 29x minus 4. Remember, once again, we're not changing anything. Any of this is just keep on going until you're done. So now I'm looking at x again, or x squared I mean, and but now my new line leader is 44x squared. So I need something to give me that 44x squared. Well, how about just plus 44, or times 44? So I put plus 44 right here. 44 goes to everything. Becomes 44x squared. 44 times minus 3. 40 times minus 3 is minus 120. 4 times negative 3 is 12, so it's minus 132x. 44 times negative 2 is minus 88. And don't forget to change all your signs. That makes that a minus, makes that a plus, makes that a plus. So your final answer, that goes away. You're left with 161x plus 92. And that's my remainder. I know it's hard to see, but that's my remainder. My remainder here is 161x plus 92. That's my remainder. So your final answer is 4x squared plus 12x plus 44. And then you add your remainder. So you add 161x plus 92. And you put it, or I'm sorry, that should be 84. I don't know why I put 92. Because negative 4 and 88 isn't 92, it's 84. So that makes that an 84. And remember, it's all over your divisor, so it's x squared minus 3x minus 2. That finishes this assignment. We're done.